Today we are going to discuss about the topic atomic structure and the periodic table, and in this topic we are going to, for the next 15 minutes, we are going to have a snapshot, like quickly review about some basic concepts which are required for thorough understanding of this topic. So we shall begin. We shall learn a few basics. These are the objectives which we need to cover, and after this we are also supposed to we shall discuss a bit about the periodic table of elements also. So let's begin our class. So my first question before we begin our session is, what would I call a fish without an eye? So the answer for this, if this is like, if I would ask the student to answer this question, and if they don't pick, it would be fish. That's it. It's an icebreaker which usually I introduce inside my presentation, so that students get more they come up to this place. Okay, so yes, when we start our let's begin our discussion on the periodic table of elements. So what exactly? So the name itself indicates that it is the periodic table of elements. So very first important thing that we need to know about this thing is it's that table where I would get all the information about all the elements which are present in this whole universe. So I won't find, if someone asks me like, where can I find the water, the basic thing, then of course, because water is a compound, so we won't be able to find it out in this periodic table of elements. So it's all about the elements. So we would be able to find out the oxygen, the hydrogen, which is the water is composed of. So elements, what are elements? So the basic difference between the elements and the compound is that the elements are those substances which are made up of the same type of atoms, whereas compounds are those substances which are made up of two or more different elements which are sharing a chemical bond between them. So this is one basic difference between the elements in the compound, and this periodic table depicts is a small piece. It's a very pretty much we can say it's a systematic approach to study, because all of a sudden if you go to study about all those compounds which are present inside the universe, then it would be a huge chaos, right? So to make a systematic study, to make us understand about all the compounds, so this periodic table is a very important thing for us. So before we begin, how these elements, so now we know, yes, this periodic table is all about the element. Now immediately the question flashes in our mind is like, why only first comes the hydrogen? Why not we start with the gold first, because it's very precious? Why can't we start with the something like the copper, which is found so abundantly, or aluminium, which is found so abundantly? But answer to this question is, all the elements in this periodic table are arranged or organized in the increasing order of their atomic number. Now here comes a new term, atomic number. What exactly the atomic number is? Now atomic number, like here also we can see, like around each element some number has been mentioned over there. So what is this all about? So if we let's see this now. Around every symbol, let it be the hydrogen, okay, we would find some number would be mentioned like this, or like it's something like this. Or if we see around carbon also, the basic one, we would find this. So this number which is written at the bottom is called as atomic number, whereas this number is called as, which is present at the topmost stack, that is called as atomic mass number. Now what is the difference? What exactly these two things we have already you must have already studied in your class 10. What does these two numbers indicate? Now atomic number, now we know, like coming back to our presentation, now this is what the structure of this thing depicts, the structure of an atom. This is how the structure of atom is all about. Basically, atom is, what is an atom? Atom is the smallest indivisible particle which cannot be broken down further into small pieces by following any chemical method. Okay, that is an atom. So Basically, atom consists of three subatomic particles. First one is protons, another one is neutrons, third one is electrons. Protons are positively charged particles, neutrons are neutral, that means they don't carry any charge on them. Electrons are negatively charged particles. Now, what if we see this structure of atom like resembles a lot with our solar system. What is our solar system called as? Our solar system is called as a heliocentric model. Now, what does this huge big name means is like heliocentric, like the sun is located at the center and all the planets keep on revolving around the sun. This is what our solar system basic idea. Similar is the case with the structure of atom like this. Now, inside this structure, at the center is located the nucleus. Okay, the center portion of an atom is called as nucleus. Now here, all the mass of the atom is concentrated at the center. Okay, why do I say like this? Because all the number of protons and neutrons are present, they are situated at the center, whereas negatively charged electrons keep on whizzing around the nucleus all the time. Okay, electrons are said to be like they keep on moving. Okay, they are not something we can't touch or we can't set it like we won't find it as something like solid. In fact, they keep on moving continuously they are moving. Whereas protons have got a mass of 1 unit, neutrons have got a mass of 1 unit, electrons mass is so less that we can ignore it. Okay, so therefore for that reason we call it like this. Nucleus consists of the protons and neutrons. All the protons and neutrons are, you will find at the center, that is at the nucleus, and all the electrons are revolving around the nucleus like this. Now, and electrons are distributed in various shells, like our planets keep on revolving around the nucleus in one particular orbit, right? Similarly, same thing happens with the structure of atom also. We know that. Now, what does, coming back to our discussion, what was an atomic number? So, inside any neutral atom of any element, pick up any element, you would find the number of protons is equal to the number of electrons. The number of protons is equal to the number of electrons. That means the number of positively charged particles are exactly equal to the number of negatively charged particles. For that reason, the atom, pick up any atom of any element, it is like it does not carry any charge on it. If it carries a charge on it, then we call those substances as ions. Okay, not the atom. So ions are the charged species. This is the basic difference between the neutral atom and like the ions, right? So this number. So now we know one more important thing, that the number of protons is equal to the number of electrons. So atomic number indicates the number of protons or the number of electrons. Okay, so whereas the atomic mass number indicates what? It is the sum of total number of protons and total number of neutrons in any atom. So here, if we see, coming back to our periodic table, so all these elements in this periodic table are arranged in the increasing order of their atomic number, not the mass number. That is all the elements. Like here we can see the number 1, 2, 3, 4, 5, 6, 7. So these 1, 2, 3, 4 indicates what? These are the atomic number. That means these are the on the basis of their increasing order of the protons or electrons, all these are. So when we say the atomic number of hydrogen is 1, that means what? That means hydrogen, like when we say, let us have a quick look at the hydrogen atom. So when we say its atomic number is 1, that means hydrogen has got 1 proton, 1 electron and no neutrons. Why? Because its atomic mass in this thing is 0. Okay, so 1 proton, the proton with the black one indicates the proton. This carries a positive charge which is found inside the nucleus, whereas the red dot indicates the electron, which is a negatively charged particle that keep on revolving around the nucleus all the time. So is the case. Let's move forward now. Here's another atom of helium. Helium has got its atomic number is 2. That means it has got 2 protons, 2 electrons, and since the atomic mass number of helium is 4, therefore it's like the sum of protons and neutrons. So when atomic mass number is 4, and we know that from the atomic number that its number of protons is 2, so 4 minus 2, we know that there are 2 neutrons. This is how the helium is. Now moving forward, so this is the basic concept about the mass and the atomic number. Proton's mass is of 1 unit, okay, and it carries a charge of positive 1. Neutron's mass is of 1 unit. It's neutral, that means it does not carry any charge, so its charge is 0. Whereas electron's mass is so less that we can ignore it, right? Therefore, we are considering, since we ignore the mass of the electrons, so its mass is 0, whereas its charge carried by the electron is negative 1. Okay, so when we move across the periodic table, we often come to see this height like helium 4, 2. So this is the atomic mass number, this is the atomic number. Okay, that is a mass number is the sum of the protons and the neutrons. Similarly, this is the symbol of an element, and this is the proton number, or the very obviously, yes, the number of protons or the number of electrons, right? That is what is meant by the atomic number. Okay, now so is the case. Now when we move across, if we see further, if we talk about the periodic table, okay, now inside the periodic table, how there are 7 periods. Okay, periodic table, as this is a very systematic thing. Okay, so each periodic table consists of 7 periods, 1, 2, 3, 4, 5, 6, 7 periods, and 18 groups are there. So all those horizontal lines are called as periods. All those 18, how many vertical things are there? 1, 2, 3, 4. So if we counted them, these vertical things are called, these vertical columns are called as groups. These horizontal rows are called as periods. There are total 18 groups and 7 periods inside this periodic table. Okay, and further we can see all those elements which belongs to the same group are said to be, like, they are said to form a family. Like if we see like the lithium, sodium, potassium, rubidium, cesium, strontium, all these belongs to the same family. This family is called as the alkali metals, right? So if you see, so basically this periodic table was given, the major pioneer work about this periodic table was done by the Mr. Mendeleev. Okay, and he gave us like and after that so many changes were being introduced to the modern periodic table. Earlier were the time when these elements were organized on the increasing order of their atomic mass number, but modern periodic table, these days the periodic table which we are seeing, we are so blessed that we have, all the work is already being done by so many scientists. So like all the elements which are present in the periodic table, they are arranged in the increasing order of their atomic number. Okay, so there are 2-3 important points that we need to remember about the periodic table. Like the periodic table, all the this is how can we describe the periodic table? Again, this is that table. Like when we want to learn some differences, most common thing, like from our junior classes, what do we do? We make a table, find the differences among these two compared. When we are comparing, what do? We write it down. Like when we want to study something, like some differences, that is A, that is B, these are the points, that is what is it. So we compare this way, right? So this is a very systematic approach. So is the case with the periodic table also. It arranges all the elements in group according to their properties. That means what? That means this vertical thing, the arrow, indicates that this is a group, and all those elements which are belonging to the same group, they are said to be, these vertical columns are called as groups, and they show similarity in their properties. Okay, and they forms a one family. Okay, like elements elements, like all those members which belong to the same family, they share the same surname. Same is the case with this element. So like since this lithium, sodium, potassium, all of them belongs to the same family, so they shows similarity in their properties. Sodium, potassium, rubidium, all of them react very, very vigorously with water. This is one of the common reactions. So is the case with the halogens also. Okay, so we shall discuss about that. So this lithium, sodium, potassium, rubidium, cesium, francium. Okay, now why hydrogen is not included in that family? Because hydrogen's position is not being fixed in this periodic table. Just to maintain the symmetry, we have placed it. But like if you see the zigzag line, okay, the famous zigzag line, which is called as which constitutes the green color, these elements are called as metalloids. Metalloids means these are those elements which shows few of its properties, like they resemble a bit about, like the metals, they resemble a lot about non-metals also. As since these elements shows both the properties of the metals and the non-metals, so they are called as metalloids, right? So all those elements which are present towards the right hand side are called as non-metals, whereas all those elements which are present towards the left hand side are called as metals. So hydrogen is the only non-metal which is kept above this metal. So hydrogen does not come under the category of the alkali metals, right? So if we see further, if we talk about the periodic table, so periodic table we have understood, like we already have seen, like since the periodic table is that place, that is it is that position where we can find all the elements are placed in the systematic approach. So elements belonging to the same group show similarity in the properties. Now why is it so? Why they are showing similar behavior? Now the reason for that lies in the fact that all those elements which belongs to the same group have got the same number of valence electrons. Now what are the valence electrons? Valence electrons mean those electrons which are present in the outermost shell. Okay, so since they have, like if we, so what does it mean? What does it mean? Like if we see like lithium, sodium, potassium, since all these elements, so these belongs to the same group, that means they would have the same number of valence electrons. That means they have, like lithium, sodium, potassium belongs to the group number 1. Group number indicates the valence electron. That means all of them have 1 electron in their outermost shell. Now, okay, does it mean like this? What does it, the immediate next thing comes to my mind is, does it mean like the beryllium, magnesium, calcium, which belongs to the group number 2, has got the valence electrons too? Then yes. Answer to that question is yes, because they belongs to the group number 2, therefore their valence electron is 2. That means they consist of, like all the one group elements have 1 electron in their outermost shell, whereas all the alkali metals have, alkaline earth metals have 2 in valence electrons. Now if we see the boron element, they have the valence electrons number 3, carbon is 4, nitrogen is 5. So this is, whereas these elements which are found on the extreme right hand side are called as noble gases. So likewise, group number, in short, the group number indicates the number of valence electrons. Now when we, one more important thing is this, when we move from one element towards another element, the atomic number increases by 1. That means what? That means what? That means since the atomic number of lithium is 3, that means it has got the presence of 3 protons and 3 electrons. But when we move from lithium to beryllium, its atomic number becomes 4. That means it shows the presence of 4 protons and 4 electrons. Therefore, what does it mean is, when we move from lithium to beryllium to boron to carbon to nitrogen to oxygen to fluorine to neon, in their outermost shell, each time when we jump from one element to another to another, each time 1 electron and 1 proton is being introduced inside the atom, inside the valence shell. Therefore, these are the noble gases. That means these are those elements these are those elements, like it's something which are fully satisfied. They are accommodating maximum number of electrons, as many as they can. That means what? That means like when we have it abundant amount of food. Okay, now there is no scope of entering even one single piece of rice also. Then if someone asks, okay, please eat one more thing, please, you need to eat it, we won't eat. Why? We are fully satisfied. We are full now. So is the case with these noble gases elements also. What does we do? Like since they are accommodating as many electrons as they can, so these are fully satisfied. So these elements does not participate in any sort of chemical reaction. Okay. Therefore, these elements are said to be inert elements, or they are called as noble gases are highly unreactive. Okay. That's the reason. Further, and when we move from one shell to another, now we have already seen that periodic table. So this was about the thing in the periodic table. Now there's one more fact. What we have understood about this thing is, when we move from all the elements are arranged in the periodic table in the increasing number of their atomic number. So when we move from one element to another, one electron and one proton is being introduced inside the structure. Okay. So group number, in short, the group number indicates the valence electrons. That means if any element is belonging to the group 1, then it means all those elements would show the presence of one electron in their outermost shell. Now, period number tells us about how many electron shells are found in that elements. That means, like if we see, like since the hydrogen, let us take with the example, since the hydrogen and helium belongs to the period number 1, that means what? That means their structure is showing the presence of only one shell. Okay. When we move towards the another period, that is which consists of the helium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. So all these elements show the presence of 2 valence shell around the nucleus. If we see the third, so all those, in short, the period number tells us about the electron shell. So when we jump from one period to another period, the extra electron shell is introduced into the structure. Okay, so period number and group numbers are equally very informative. Okay, so like lithium has 3, so electrons are distributed. Since it is belonging to the period number 2, which indicates that it has got the 2 valence shell, that is 2 electrons are present in the first shell and 1 electron is present in the another shell. So therefore we can understand this in a way like these, like I said, these elements, this group is called as lithium, sodium, potassium, rubidium, cesium, strontium. These are called as alkali metals. They are group number 1. Okay. Second, if you see, their position is it is present in there. Similarly, if you see in the periodic table, this element at the extreme right hand side, these are called as the noble gases, which includes helium, neon, argon, krypton, xenon, radon. Further, if we move further, then before this group 0 lies the group 7, which constitutes the halogen. Halogens are like the fluorine, chlorine, bromine, iodine, astatine, which are very reactive elements. This is about the basic of all the few we have, because of some limited time we have not covered all the topics about the periodic table. Yes, there is lots of things more to be discussed about this topic, but this is just a general introduction about this periodic table. So this is all about the periodic table. Let's end our session here only. So let's revisit our objective before ending our session. So by the end of this session, we have discussed the periodic table of elements. Now we also know, we have discussed about the structure of an atom, how the atomic structure is, like it consists of nucleus, it consists of an electrons whizzing around the nucleus all the time. And these electrons, no, it's not like they are floating everywhere. No, they follow a particular path. That path is called as shell, energy shell. Okay, and we also know, like we have also identified how the electrons are filled into their energy shells, like we saw the atomic structure of the hydrogen, helium, lithium, so on. So these are the objectives which we have covered in this session, in this small session. Yes, if you have any doubt about the session, the students can ask me at any point of time. So it's all end from my end. Thank you so much for being so patient on me.